Welcome to the Algebra Final Review. This is part 3 of Standard 9, and in it, as I mentioned before, we're going to work on the graphs of quadratics and parabolas, and we're going to just talk a little bit about answering some questions, even though they're not on this review sheet. We are going to do problem number 2 under this standard. First, I want to look at a graph. If you're going to be successful, you've got to basically have a good idea of the terminology that we're going to use on this graph. And what we're going to do, this is the graph of x squared minus 3x minus 10 equals y. When I'm trying to find the solutions, I want to know when this doesn't equal y, but when this equals 0. So I went ahead and set it equal to 0. If I factored it, I would get x plus 2 and x minus 5 as my factors. Okay? And so that tells me that x equals negative 2 and x equals 5. Remember from the first part of this standard, we said that if we can look at a graph, the solutions will be where it crosses the x-axis. And that's what we see here. It crossed at negative 2 and it crossed at 5. There's a couple of other key points. Those solutions, ones in red, we call them solutions. We've called them roots. Some books will call them zeros. And, of course, we also call them the x-intercepts because that's where they cross the x-axis. Now, this down here is either the lowest point or the highest point, depending if it's opening up or opening down. If it's opening down, it becomes a maximum point. This maximum or minimum point is called the vertex. So if a question asked you what the most sales were or what the deepest part of the ditch was, you could look for the vertex and it would tell you where that is. Okay? You want to consider both the x and y value on that. This orange dotted line going right here is the axis of symmetry. It always is exactly halfway between the two solutions. So if you can find halfway between your two solutions, you can find the location of the vertex, or you can find the location of the vertex by plugging it back into your equation. The green spot right here is where it crosses the y-axis. So quadratics have y-intercepts also, and their y-intercept is real easy to find. It's basically the same place as the y-intercept was when we were doing linear. It's the constant term when it's in the correct form. And so this one actually does cross at negative 10. And so your question in the book asks you to find or to graph this using just the intercepts. So there's 3 intercepts, 2 x's and 1 y. So here's your problem. And let's go ahead and let's do we know what the y-intercept is going to be. It's going to be at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be right here. Remember, I'm using a scale of 1, and I'm leaving that off right now just so you won't have to deal with all of the stuff on the graph. Now I need to factor this. I could factor using the quadratic formula, in which case I'd need to remember to put a 0 in for x for the linear term, or I can use it by factoring. These look like easy numbers, so I think I'm going to do it by factoring. So I'm going to say 0 equals 2x squared minus or plus 0x minus 8. Okay? I see that everything here can be divided by 2, so I'm going to simplify that and just say it's 2 times x squared plus 0x minus 4. Okay, now this is what I'm going to use for my diamond and my rectangle. Let's see, x squared, negative 4, and 0x. Okay, and then the top of the diamond is going to have negative 4x squared. Okay, two numbers that multiply to negative 4 and add to 0, 2x and negative 2x. Okay, so I put those over here. Factor an x out of that row, x times 2, and x times negative 2. So I get as my two factors x minus 2 and x plus 2. If I solve those by setting them equal to 0, I will get these two values. So I now know where those intercepts are. So those intercepts are, there's one here at -2, and there's one here at +2. If I didn't know where the center was, this is what I would do. I would take my two x's and go, what's halfway between 2 and -2? Easy way to find that. 2 minus -2, I think it is. Let's see. Sorry, 2 plus -2 is 0, and 0 divided by 2, that's how you find a mid place. So the middle place would be right here, and I could just plug 0 in this time to even into this. I could plug 0 into this, and it would tell me what y value where the vertex is. So now I'm ready to graph. So I'm just going to go ahead and I could put some other points on there, but basically now I also wanted to show you on here. So if I asked you what the deepest the ditch went, you would say it went down to the y value of -8. Where was it at ground level would probably approximate with the y-axis, the x-axis. Now, I've gone ahead and I put this in on the calculator. I went ahead and typed this in, and I want to show you something. You can use this to also verify your graph. You may need to do some other thing. You may need to do what I did before to be able to graph it, but this is a way to check it really good. So I'm going to go ahead and go to graph, and that's what my graph should look like. I got an idea of the center, and I can use trace to move the cursor and find all the different x and y, bunches of different x's and y values. I'm going to zoom in a little bit just so I can get a better look. So zoom box, it's my favorite one to use. Move it to where you want the corner of your box to be, press enter, and then I'm going to come over here, and those are the places I'm really interested in. Looks like it crossed at -2 and +2, and if I just even move my cursor down here to where it looks like it crossed, looks like it says it's crossing at about -8.1. It's actually -8, but remember when you graph it can be a little bit off. You can also go to the table function, and it will actually list a bunch of different x and y values, like 0 and -8, 1 and -6, 2 and 0, 3 and 10. You want to make sure to get, it's going to be a parabola, so you want to make sure to get some on both sides. Okay? Well, I hope this helps, and good luck.